Hello and welcome to Mike's Development Zone. In Java, a record is a special kind of class introduced in Java 14 as a preview feature and officially in Java 16.1.6 that significantly simplifies the creation of data classes. Records are ideal for immutable data carriers and automatically provide boilerplate features like constructors, equals method, hashCode method, and toString methods. They are under the hood by default. Here is a basic comparing class and its equivalent as a record. So now we will look at the classic Java data class before this feature was introduced. So now we're going to look at the class person. Here you can see two fields, name and age, and it has a constructor. As you can see, they are immutable since they are implemented with dependency injection. You can see the final, and you can see them assigned only in the constructor, and they can only be assigned in the constructor, as you know. And then we have some getter methods. They get named in and they get age in order to read the data. And we will have the typical methods of a data class. We will have the equals, the hashCode, and the toString method, as you can see. So here in the toString method, you will have a person with a name and age. We'll try to keep this example simple. And how do you declare this in a record? By just making the data class into a record, we automatically provide canonical constructor, that means immutable fields, as in this case, name and age. And we automatically get the getter methods in the form of name and age. And the implementation equals hashCode and toString are automatically in the record class. So now let's have it as contrast to the classic data class. They require explicit definition of constructor, getter, equals, hashCode, and toString. So what is the advantages of record? It's much cleaner and more concise. It has built-in immutability, like we said, the fields are final and so on. It's an idle class for the primary purpose is to store data, making it easier to write maintainable code. So in summary, record drastically reduce boilerplate code while offering the same functionality as a typical data class. So the key difference between the classic data class and the record is that records are final and non-extendable. In Java, records are a special kind of class introduced to reduce boilerplate code for data classes. A record is implicitly final, meaning it cannot be extended by another class. Here's why this limitation is actually a feature and not a drawback. Number one, simplicity and focus. The core purpose of the record is to serve as a concise, immutable data holder. By disallowing inheritance, Java keeps the record simple and focused solely on carrying data. Allowing subclasses could add unnecessary complexity to their design. Number two, immutability and safety. Records are designed to be immutable. As you know, the fields are final by default. If subclassing were allowed, it could lead to violation of immutability, defeating the purpose of record as safe, immutable object. Number three, it has consistency in behavior. Since records are non-extendable, the behavior of a method like equal, hashCode, and toString is guaranteed to remain consistent. If subclassing were allowed, this method could be overridden, leading to unpredictable behavior in different parts of the code. As I was describing, it offers consistency in behavior. And number four, thread safety. Because records are immutable, they can be safely shared between threads without worrying about concurrent modifications. This is essentially in multi-threaded environments. Being final ensures that record stays immutable and maintain this thread safety. So why is non-extendability good for records? It is due to simplicity. Records are meant to encapsulate data and provide a clear contract. By being final, they eliminate the potential complexity and ambiguity that comes with subclassing. It is immutable by design. Their fields are final by default, and the inability to subclass them ensures they remain immutable, enhancing code safety. It provides readability and maintenance. When you see a record in code, you can instantly understand its behavior and trust that it won't change in unexpected ways due to inheritance. It makes records easier to maintain. Additional features in records. Although records reduce boilerplate code, they still allow for a certain customization. For constructors, you can define additional validation logic. And for static fields and methods, records can contain static fields and methods to support additional functionality. And when it comes to methods, you can still add custom methods to a record for a specific logic beyond the automatically generated ones. Now let's backtrack a little. And now we're gonna try to do some printouts on our data classes. Let's go to this class called person main. Here we have the classical person data class. We have typed in Bob 25, and we have the print of the toString name and age and so on. There's nothing strange here. We can have a fast look through the data class. As you can see. Here's the toString and so on. And here we're printing out the second data class, which is the record. I can show you. Here's the record, person 2. Here, and with practically printing the same thing. But notice we don't say get anymore. It's a more concise method name now in the record. It's called name and age instead of get name, get age. So let's run it, see what's up. And what did we see? As expected, we can see the classical person here, Bob, 25 years old. And we have the record corresponding to the classical data class. Now, just to make a difference, we call him Bobby, and he's 5 years older, 30 years old. Well, nothing strange with this. And if you go back to the record class, you can see we have defined a static field, which is a constant. And we have printed it out in an additional method for greetings. So let's add that in example 2 here. Call it. So let's see what's coming out when we play it or run it. So as expected, we have the greeting of the record class. Hello, my name is Bob. It's exactly as expected. Nothing strange with this. And now let's do a final test. Let's see that this customized constructor with a validation kicks in when we put a negative value. So let's see what's going to happen. Of course, we expect it to fail, but that's for demo purpose. We're going to run it. And we can put like a number 3 after this. Over here. Number 3. And we'll put a negative value. Will be -2. Be 2. Oh, all right. Let's run it, and we expect an exception. So let's see. Yeah, here we have it. Illegal argument exception. Age cannot be negative. As you remember, is exactly what was typed in the exception message. Thank you for listening, and I wish you happy coding. Bye bye.